Okay, so we're going to be working on the review sheet. So let's take a look at number 1. It says to factor completely. So number 1 is 15s minus 60s to the third power. So I noticed that there is a GCF. So let me rewrite this. So it's 15s minus 60s to the third. So there's a GCF, and the GCF is 15s. So I factor out the GCF. And then I'm left with 1 minus 4s squared. And then I noticed that I could factor this in the middle here. It's the difference of two perfect squares, so two parentheses. Take the square roots. So it's be 1 plus 2s, 1 minus 2s, and then bring down the 15s. So let's take a look at number 2. Alright, so let's take a look at number 2. And number 2 is 5x to the fourth minus 35x to the third minus 45x squared plus 315x. So I notice that there's 4 terms, so automatically I think grouping. So I'm going to group the first 2, and I'll group the last 2. So now we're going to do the GCF of the first group. The GCF of the first group would be 5x to the third. And then what's left is x minus 7. There's a negative here, so I put that on the outside. The GCF is 45x times x minus 7. Okay, so now my factors are 5x to the third minus 45x times x minus 7. And then I notice that in here, there is a GCF, and the GCF is 5x, so I have to factor that out. So 5x times x squared minus 9, and then I still have x minus 7. And then I notice in here, I have the difference of two perfect squares, so I have to factor that. That's x plus 3, x minus 3, bring down the x minus 7, x minus 7, and 5x. Alright, so let's take a look at number 3. Okay, so number 3 is x to the ninth minus y to the ninth. Okay, so I noticed that I have perfect cubes. X to the ninth and y to the ninth are perfect cubes, and it's the difference of perfect cubes. So I want to think of SOAP. Remember, same, opposite, always positive. So two parentheses, one small, one big. Remember, it's same, opposite, always positive. And then inside, remember, this is A, B, A squared, B squared at the end, and the middle is A times B. Alright, so over here on the side, I need to do my perfect cubes. The cube root of x to the ninth is x to the third. That's going to be my A. And the cube root of y to the ninth is y to the third, and that's my B. Okay, so I have my A, which is x to the third. My B is y to the third. Now my A, which is x to the third, but I need to square that. And then A times B, so it's x to the third, y to the third. And then B, which is y to the third, and I have to square that. So I'm just going to clean that up in there. So that's x to the third, y to the third, minus y to the third. This here becomes power to a power, multiply the powers, x to the sixth, plus x to the third, y to the third, plus y to the sixth power. Alright, and then I notice that in here, again, I have the difference of perfect cubes, so I have to factor that. So we have small, big, and then this one here, I'm going to bring down over here. So that's going to be x to the sixth, plus x to the third, y to the third, plus y to the sixth power. Alright, so now we're going to need same, opposite, always positive. And now we need the cube root of x to the third is x, and that's my A. The cube root of y to the third is y, and that's my B. Alright, so I need x minus y, and then x squared, y squared at the end, and then x times y. So this is my answer, this whole thing right there. Okay, so let's take a look at number 4. Okay, so number 4 says to determine the nature of the roots. That's describing the roots as real, rational, equal, real, rational, unequal, real, irrational, unequal, or imaginary. So remember, that's the discriminant, b squared minus 4ac. All right, so let's start with number 4. So number 4 is x squared minus 3x minus 2 equals 0. All right, so my b is negative 3, so it's negative 3 squared minus 4 times 1 times negative 2. So that you can just plug in the calculator, you get 17. So remember, you want to think about on the side, number plus minus the square root of 17 over a number. Are they real? Yes. Rational or irrational? You can't take the square root of 17, so that is irrational. And they are unequal because you are adding and subtracting the square root of 17. All right, let's take a look at number, number 5, which is 5x squared minus 2x is equal to negative 1. So the first thing, you have to add 1 to get it to equal 0. 5x squared minus 2x plus 1 is equal to 0. Okay, so I need my b, which is negative 2, so it's negative 2 squared, minus 4 times 5 times 1. Just plug that in the calculator, you get negative 16. So think about number plus minus the square root of negative 16. You have a negative under that radical. That means it's imaginary. Okay, so let's take a look at 6, applications of it. Okay, so it says, given 2x squared plus 4x plus m equals 0, determine the values of m that would make the roots of the quadratic real, rational, equal. Okay, so let me write that down. That's 2x squared plus 4x plus m is equal to 0. Now, in order for my roots to be equal, that's the key word here, my discriminant, b squared minus 4ac, discriminant has to be equal to 0. All right, so I'm going to plug in a, b, and c. So I have 4 squared minus 4 times 2 times m is c equals 0. 16 minus 8m equals 0. Minus 16, we can add 8m, whatever. Negative 8m equals negative 16. Divide by negative 8. M is equal to 2. So when m is equal to 2, my roots will be real, rational, and equal. Remember, that's tangent to the x-axis. All right, let's take a look at number 7. So number 7 says, given the equation, which value of m would make the roots of the quadratic equation real, rational, and unequal? And then there's choices. So I have to solve this first. So let me write it down. I have x squared plus x plus m is equal to 0. Okay, so I want my roots to be real, rational, and unequal. So that would mean I want my discriminant, b squared minus 4ac, to be greater than 0. All right, so let's plug in our numbers. We have 1 squared, that's b, minus 4 times a, which is 1, times c, which is m, and that's greater than 0. So it's 1 minus 4m is greater than 0, minus 1. Negative 4m is greater than negative 1. Divide by negative 4. Remember, when you divide by a negative, you flip the sign. M has to be less than 1/4. Now, this is a multiple choice. So let's look. Let's see which one here is less than negative 4. And that would be choice A, which is negative 1. All right, let's take a look at 8. Okay, so number 8 says, given the equation, which value of m would make the roots of the quadratic equation real, irrational, and unequal? All right, so let's write number 8 down. So that's x to the 4th plus 4x plus m is equal to 0. All right, so if I want my roots to be real, irrational, and unequal, that means my b squared minus 4ac, my discriminant, has to be greater than 0. So that's 4 squared, that's b, minus 4 times a, which is 1. And, sorry, before I continue, this should be a square. Times 1 times m is greater than 0. All right, so that's 16 minus 4m is greater than 0. So I'm going to minus 16. I get negative 4m is greater than negative 16. divide by negative 4. Remember, when you divide by a negative, you have to flip the sign. So m is less than 4. All right, so now let's look at our choices. So m has to be less than 4. So which one of these choices here is less than 4? That would be A, choice 1. 1, which is A. All right, and let's take a look at 9. Okay, so 9 says, given the equation, determine the value of m that would make the roots imaginary. Okay, so let me write down the equation for number 9. So it's 2mx squared plus 4x plus m is equal to 0. So I want my roots to be imaginary. That means b squared minus 4ac has to be less than 0. It means it has to be negative. So it's 4 squared minus 4 times 2 times m is less than 0. 16 minus 8m is less than 0. So minus 16, I get negative 8m is less than negative 16. Divide by negative 8. Remember to flip the sign when you divide by negative. When m is greater than 2, you will have imaginary roots. All right, let's take a look at 10. It says, explain how you would distinguish if the roots are real, rational, unequal, or if the roots are real, irrational, and unequal. All right, so this is just asking if you know about the discriminant. So when the discriminant is positive and a perfect square, the roots are real, rational, and unequal. When the discriminant is positive and not a perfect square, the roots are real, irrational, and unequal. Okay, so that's 10. Let's take a look at 11. Okay, so all these here says determine the roots in simplest a plus bi, in simplest radical form or a plus bi form. So these are all solving the roots, finding the roots. So we can use factoring, possibly quadratic formula, or complete the square. Okay, so let's get started. Number 11. Just going to move everything up, or to the side actually. Okay, number 11 is 3x squared plus 2x minus 3 is equal to 0. All right, so I look at this and I notice that I don't have a 1 in front, so I do not want to complete the square. So I'm going to use the quadratic formula. That's x equals negative b plus minus the square root of b squared minus 4ac all over 2a. All right, so b is 2, so it's x equals negative 2 plus minus the square root of 2 squared minus 4 times a, which is 3, times c, which is negative 3, over 2 times 3. So I get x equals negative 2 plus minus, plug in what's under the radical, over 6, and what's under the radical comes out to be 40. You do have to simplify that. Square root of 4 is square root of 10, which is 2 the square root of 10. So I get x is equal to negative 2 plus minus 2 the square root of 10 over 6. You want to make a heart to see if you can simplify. What goes into negative 2, 2, and 6? That would be 2. So you get negative 1, 1, 3. So x equals negative 1 plus minus the square root of 10 all over 3. All right, and let's take a look at 12. Okay, 12 is x plus 1 squared plus 64 is equal to 0. Okay, so notice that I have this x plus 1 squared. You can do x plus 1 times x plus 1 and double distribute, but I kind of like, it looks like maybe it's in a process of completing the square. If I just take this 64 and minus it. So remember, because when you complete the square, we have a parentheses squared. So it kind of looks like completing the square in a step already. So I take the square root of both sides. That cancels that out. So I have x plus 1 equals. Remember, you get plus minus the square root of negative 64. So this is plus minus. The negative becomes an I. The square root of 64 is 8. So it's plus minus 8i. So now I'm going to minus 1. When you minus 1, that goes in front of the plus minus. So it's x equals negative 1 plus minus 8i. Okay, let's take a look at number 13. Number 13 is x squared is equal to 3 times x plus 3. So we are going to have to distribute here. So we get x squared equals 3x plus 9. And now I'm going to move everything over to the left to keep x squared positive. So minus 3x minus 9. So I get x squared minus 3x minus 9 equals 0. So I notice here that I do have a 1 in front. So possibly I could complete the square or not. Yeah, I don't think so because look at the middle term. It's not even. If I complete the square, I'd have to do half of this number and I get a fraction. So I don't want to do that. So I'm going to use the quadratic formula. Okay, so I get x equals, this is the formula, negative b plus minus the square root, b squared minus 4ac all over 2a. All right, so I get x equals, opposite what b is negative 3, so it's 3, plus minus the square root of negative 3 squared, minus 4 times 1 times negative 9, over 2 times 1. So x equals 3 plus minus, plug in what's under the radical, over 2. When you plug in what's under the radical, you get 45. And now we're going to simplify 45, the square root of 9, square root of 5, which is 3 the square root of 5. So then I get x equals 3 plus minus 3 the square root of 5 all over 2. Can I reduce? Is there a number that goes into 3, 3, and 2? No, so it's just 3 plus minus 3 the square root of 5 all over 2. Okay, number 14. And 14 is x squared minus 14x plus 37 is equal to 0. All right, so I notice here that I have a 1 in front, which is good. And my middle term is even, so I want to complete the square. So I'm going to subtract 37. X squared minus 14x is equal to negative 37. Now I do half of negative 14, which is negative 7. Square it, you get 49. You're going to add it to this side and over into here. So that we get x squared minus 14x plus 49 equals negative 37 plus 49, which is 12. And then I'm going to factor this side here. Remember, we get the same parentheses, x and x. What goes inside the parentheses is what we got when we did half of b, which is negative 7. So now I have x minus 7 squared is equal to 12. Square root both sides. So I get x minus 7 equals plus minus the square root of 12. Now remember, you want to simplify the square root of 12. So what perfect square goes into 12? 4 times 3. So this is plus minus 2 square root of 3. And then add 7. Remember, the 7 goes in front of the plus minus right in here. X equals 7 plus minus 2 the square root of 3. Okay, number 15. 15 is x minus 6 times x plus 5 is equal to 12. You are going to have to double distribute. So x times x is x squared. X times 5 is 5x. Negative 6 times x, negative 6x. Negative 6 times 5 is negative 30 equals 12. So this is x squared minus x minus 30 is equal to 12. Minus 12 to get it to equal 0. X squared minus x minus 42 is equal to 0. So this is actually factorable, right? Because I notice right away, because there's really a 1 here, that this becomes negative 42x squared. And what numbers multiply the 42 minus to 1? So you got that. That would be 7 and 6. Different signs. So I need a negative 7, a positive 6 to get negative 1. Okay, factor by grouping. Obviously, you don't have to do it like this. If you didn't realize that you can factor, you can use quadratic formula. So GCF is x, so I get x minus 6. GCF is positive 6x minus 7. And then I get x plus 6, x minus 7 equals 0. T-chart, we get x is equal to negative 6 and x is equal to positive 7. Okay, so let's take a look at 16. So I have to flip the page, so you guys need to flip the page. Okay, so number 16, we want to simplify I to the 32 plus 3i squared minus 4i to the 52 plus I to the 5th minus I to the 11th. Okay, so plug in I to the 32 into your calculator. So that's I part I, caret key 32. We get 1 plus, actually, let me rewrite this. So that was I to the 32 I to the 32 plus 3i squared minus 4i to the 52 plus I to the 5th minus I to the 11th. All right, so plug in I to the 32 in your calculator, you get 1. We should all know that remember I squared is equal to negative 1. So positive 3 then becomes negative 3. Minus 4i to the 52 is just negative 4. I to the 5th is I. Minus I to the 11th, or if you plug in negative I to the 11th, you get a negative I, and then that becomes positive I. So it's a positive there. So I have 1 minus 3 here is negative 2 minus 4 plus 2i, and then that's negative 6 plus 2i. Okay, let's take a look at 17. That's simplifying the square root of negative 50 plus the square root of negative 128. So I'm going to start with the negative underneath the radical. It becomes I, the square root of 50, and I'm going to simplify the square root of 50 to the square root of 25 and the square root of 2. So this becomes 5i, the square root of 2. So now I have I, the square root of 128. So that's the square root of 64 times the square root of 2. And the square root of 64 is 8, so it's 8i, the square root of 2. So it's 5i, the square root of 2, minus 8i, the square root of 2. So just subtract the coefficients, and that's negative 3i, the square root of 2. And let's take a look at 18. All right, so remember, this means that means inverse. And inverse means to switch x and y. All right, so I'm going to rewrite my equation. So that's f of x is equal to x to the 4th plus 3 over 2. I'm going to change f of x to y equals x to the 4th plus 3 over 2. Inverse means to switch x and y. So I switch x and y. I get x equals y to the 4th plus 3 over 2. And now I'm going to put x over 1 and cross multiply so I can solve for y. So I get 2x equals y to the 4th plus 3 minus 3 from both sides. 2x minus 3 equals y to the 4th. And now how do you get rid of a 4th power? Well, you take the 4th root. Right? If you have to get rid of a square, you take the square root, take the 4th root. So that cancels that out. So I get y equals the 4th root of 2x minus 3. And then you should write it using inverse notation. The inverse of f of x. Remember that inverse notation has that negative 1. The 4th root, make sure that 4 is inside the check mark. 2x minus 3. So remember, this here, be careful. Don't write it like this. Okay, this 4 has to be inside the check mark. Otherwise, it'll be wrong. All right, and then let's take a look at number 19. All right, so number 19 says the width of a rectangle is represented by x to the 2nd minus x minus 5, and the length is represented by x squared minus 9x minus 11. The perimeter, so they give us perimeter 64, find the dimensions. All right, so I have this rectangle. The width says it's x squared minus x minus 5, and the length is x squared minus 9x minus 11, and perimeter is 64. So in order to find the dimensions, well, I'm going to have x, so I could plug x in and evaluate. So in order to get x, I'm going to have to solve it somehow. Well, if they give us perimeter, you have to use perimeter. Perimeter means to add up all the sides. So I have to add up all the sides. So remember, opposite sides are the same. All right, so this is the same as this, and this side is the same as this side. So we're going to add up all the sides. Ready? So x squared minus x minus 5 plus x squared minus x minus 5 plus x squared minus 9x minus 11 plus x squared minus 9x minus 11 equals 64. Combine like terms. So x squared plus x squared plus x squared plus x squared plus x squared is 4x squared. Negative x is negative 2x. Negative 9x is negative 11x. Minus 9x is negative 20x. Negative 5 minus 5 is negative 10. Minus 11 is negative 21. Minus 11 is negative 32 equals 64. Okay, so I notice it's a quadratic, has to equal 0, so I'm just going to minus 64. 4x squared minus 20x minus 96 is equal to 0. And then I notice that there is a GCF. You can try to factor it if you want, but I'm going to factor out the GCF, see if it helps me out a little bit. So I have 4 times x squared minus 5x minus 24 is equal to 0. All right, so now I can see that I can factor this, because when I multiply the first times last, I get negative 24x squared. Okay, so what numbers multiply to 24 minus to 5? That would be 8 and 3. They get different signs. It's positive 3, negative 8. That's how I get negative 5. Bring down the negative 24 and bring down the x squared. You can, use quadratic formula if you want to. So now I'm going to factor by grouping. All right, so I have x times x minus 8 and positive 3 times x minus 8. So I get x plus 3, x minus 8 equals 0. Remember, I had this 4, but that's really not going to do anything because having the 4 there is not going to do anything. Okay, so now I take them and I set them equal to 0. The 4 doesn't matter. So I get x is negative 3 and x is 8. Now, we are talking about length and width of a rectangle. So don't get to this point and be like, oh, I can't have a negative length. I'm going to cross off the negative 3. You have to check to make sure to see which one's going to give you a positive. You'll be surprised. All right, so let's start with my width here. I'm just going to move everything over a tiny bit here. Okay, so I have my width. My width is x squared minus x minus 5. So let's start with 8, because you probably thought, oh yeah, it's going to be 8 then. So it's 8 squared minus 8 minus 5 is that's equal to 51. So I have my width is equal to 51, so that's good. My length is x squared minus 9x minus 11, and when I plug in 8, I get 8 squared minus 9 times 8 minus 11. And you plug that in your calculator, and your length actually comes out to be negative 19. So that can't happen. So then 8 is really not my answer. It must be negative 3. So let's check. I have to get rid of all this here. Okay, so let's try that again. So if my width is x squared minus x minus 5, and now I'm going to plug in negative 3. So width is negative 3 squared minus negative 3 minus 5. So my width comes out to be 7. So that's good. And now let's do my length. Is x squared minus 9x minus 11. So the length is negative 3 squared minus 9 times negative 3 minus 11. And my length actually comes out to be 25. So those are my dimensions. My dimensions are my length is 25 and my width is 7. Okay, so study some more and have a good night and get ready for your tests.